What the general solution is looking at is what happens if we don't just solve between 0 and 2 pi. Because they could give us different domains. Sometimes you've done ones where they said solve between negative 2 pi and 2 pi. Sometimes it might have said solve between pi over 2 and 3 pi over 2. So up till now, most of our questions have given us a domain to look at and solve all the angles in that given domain. What the general solution says is if we're not concerned about the domain, if we want to consider all possibilities that work, every single angle that works, how would we do that? Well, what's going to happen is we're going to solve it like normal from 0 to 2 pi. So for example, just so that we have an example off to the side, if I was solving this equation, sine theta equals a half. You know from your pi plate that's in quadrant 1 and quadrant 2, and it's part of your pi plate, so we get pi over 6 and 5 pi over 6. What the general solution is doing, and I'll show it to you graphically, is if I draw one period of sine from 0 to 2 pi, that would look like that, right? And we've done a fair bit of graphing already. But what do we know about our sine graph? Well, it keeps on going forever. So if I was trying to figure out when is sine theta equal to a half, right? The amplitude is 1, a half would be right here. It happens here and it happens here. Well, this happens to be at pi over 6. This one happens to be at 5 pi over 6. We already know that from our unit circle. But can you see that if you kept going at a half, it would happen here and 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 so on forever. There's going to be an infinite amount of answers. Well, how do we find all of those answers? We just say to ourselves, these are going to be coterminal angles. How much of it is the jump from here to here? Well, if we take out our unit circle, that starting at pi over 6 and going one whole time around would be adding 2 pi, which is the same as the period that we have here. So we're going to find all of our answers like normal, and then we're going to add 2 pi k times, as many times as we want, where k is an integer, over and over again to each of our answers. And that's basically, remember when we did in chapter 6 all the coterminal angles with an angle, where we added 2k pi or added 360 degrees times k to find all the coterminal angles? That's basically what we're doing here in the general solution. We're finding our solutions from 0 to 2 pi, and then we're listing all of the coterminal angles with that by adding 2k pi to those answers. So instead of doing example 1, which is right under this, we are going to do these two examples instead. Here's our first example. It says solve for theta, and here is where it tells us that we want to do a general solution, that theta can be any real number. And we have 7 sine theta plus 1 equals 0. So we start by solving this like normal. You get sine theta by itself, negative 1/7. How do we get our reference angle? We go to our calculator and do sine inverse of positive 1/7. A reference angle is always with the positive angle. So where is sine negative? Sine is negative from quadrants in quadrants 3 and quadrants 4. So we plug those values in to our calculator and get those two answers. So far, nothing's changed. As far as our general solution, we've just solved from 0 to 2 pi like we normally had. The only thing difference now with the general solution is once you've done that, then you go and write it like this. So theta is equal, and I have an approximation sign there because I rounded. Theta is approximately equal to, these are the two answers that we found, and then to each of those we go plus 2k pi plus 2k pi. We draw a line here, a straight line, that just means where k belongs to the integers. So we have to learn a little bit of notation stuff, how to write a general solution. So this last step is new. This idea that we're going to take our answers that we found from 0 to 2 pi and then go plus 2k pi to each of them. So here's one for you to try. Find the general solution for 5 cos theta plus 1 equals 0. So there's the answer. I didn't show any of the work there, but you can see how you did. You would have needed to get your reference angle first. And then, since cos here is negative, you'd find answers in quadrant 2 and quadrant 3. So again, if you were unable to get those ones, I'll come around and see maybe where your mistake is. While I'm checking others, if you want to try some from the homework, try questions 5, 6, and 9.